The ForFreight project aims to make freight transport across Europe more efficient, flexible, and sustainable. By advancing multimodal logistics and promoting seamless cooperation between ports, terminals, and hinterland networks, ForFreight reduces transport costs and environmental impact and improves operational capacity and service visibility. At the core of this initiative stands the ForFreight platform, a digital ecosystem that connects diverse logistics actors and systems to optimize multimodal freight operations. It addresses the digitalization gap and fragmentation that often hinder collaboration across supply chains, offering an interoperable environment where data from different sources can be combined to solve real-world logistics challenges. Through its comprehensive library of digital solvers and innovative workflow engine, the ForFreight platform transforms raw data into actionable insights, supporting smarter decisions, greener operations, and stronger collaboration. The platform comprises a set of functions and capabilities that enable the efficient digital configuration, execution, and assessment of multimodal logistics operations, acting as a community layer that integrates existing logistics systems, digital services, and stakeholders into a common ground for efficient, data-driven, and sustainable intermodal transport across Europe. Users are first greeted by the ForFreight login page. Enter your email and password as you would on any standard sign-in screen. Behind the scenes, the platform's authentication and authorization services verify your identity and apply role-based access control. Once signed in, you'll see only the pages and features enabled for your role, with certain advanced tools available solely to developer accounts. After signing in, you land on the ForFreight homepage, your control center for day-to-day work. Scroll to explore the platform's overall concept and project objectives for quick context. At the top right, the profile menu provides quick access to the e-learning platform and log out. On the left, the main navigation groups features into Home, the current page, Request history, Marketplace of solvers and solving processes, Intermodal interface wizard, Workflow engine, Onboarding of solvers and solving processes. Going forward, we will visit and demonstrate each menu option and feature in detail, showcasing their purpose, functionality, and how they support your work within the ForFreight platform. The Solver Marketplace page presents the user with the list of solvers available to them. For each solver, there is some information present in their card, but more information on each particular solver can be visualized by clicking the Read More button. This shows additional information split in 6 different tabs where, apart from the description, the real-world problems the solver aims to solve are presented, what category the solver can be put into, what solving processes it is a part of, if any, what endpoints are available, and its intermodal interfaces. The user can also run any of the solvers available in the marketplace in order to get their output. For example, we can search for ETA prediction. By clicking the solver named ETA prediction trains run button, the user is redirected to a different page, where, after the desired endpoint is selected, the inputs required to run this solver will be in display. This solver predicts the arrival time of a train departing from Port of Galati to the selected destination. The submission form requires the desired destination and the departure time. These parameters need to be filled with appropriate values. In this example, the destination will be Bucharest and the departure time is the XTH of Y at A hours and B minutes. The values can now be submitted and the result of the solver are displayed. Going back to the solver marketplace, now searching for Container Port Dwell Time Predictor, which predicts the total stay duration of the cargo at Port of Valencia, and clicking the Run button on the solver. The user is again presented with a form with parameters required by the solver. This time, a container number and a bill of lading number. After filling in these fields with valid input and submitting the values, the results for the given inputs are now shown. This particular solver outputs its results in a TIC 4.0 format, but the duration can be retrieved from the timestamp and value here. The next solver further demonstrates the different output formats available in the platform. Search for Real-Time Tracker. The solver provides the best route from Port of Piraeus to Athens International Airport. This solver is meant to indicate the best route from and to static points at the time the request is made. Therefore, it does not require any form to be filled and can be run right away. The result of running this particular solver actually displays a map with the best route, as the output is a set of coordinates which are quite hard to understand otherwise. The Solving Process Marketplace is presented in a similar fashion to the Solver Marketplace, where a list of available solving processes, with the option to get more information or run the solving processes, are presented. By clicking the Read More button, additional information can be seen regarding the selected solving process. This information includes its overview, the intermodal interfaces it affects, which solvers are included in its execution, along with any legacy system it may use, and finally what real-world problems it aims to solve. By clicking the Run button on a solving process, click Run. The solving process's inputs are now displayed. For solving process GR_SP2, the inputs required are the time the freight leaves the port, any unexpected delay, the location of the destination, and the maximum allowed time it needs to arrive there, namely freight arrival, duration, location, and user end date time, respectively. Once this form has been filled with the required parameters, the solving process will run through the various solvers included in it and provide the user with a final output, which will be the list of the feasible flights that suffice the constraints. Indicatively, the following values can be passed. Freight arrival, October 8, 2025, 10:36. Duration 3. Location, Amsterdam. User end date time, October 18, 2025, 10:36. The user is able to see all the intermediate steps till its arrival at the airport, along with the timestamps and the list of the feasible flights that can be assigned. The steps and timestamps are the output of the solvers the solving process consists of. The request history page allows users to review the various results obtained from solvers and solving processes during previous runs. The data table can be filtered by date, time, and service. Reviewing the output of each request also allows users to download the output of the selected request. Apart from this page also contains the Analytics tab. This page allows for the visualization of graphical representations of previous results obtained from solvers or solving processes. These results are generated dynamically for every integrated solver or solving process, including any added externally via the onboarding processes the platform offers. The Intermodal Interface Wizard provides a wizard-like guided path to run solving processes. Start by selecting the desired intermodal interface, for example road to air. Then choose the real-world multimodal transport problem for that interface. Next, pick the solving process suggested for your selection. The wizard then presents a focused input page with only the parameters required for that process. Complete the inputs and click Submit. Again, the solving process will run through the various solvers included in it and provide the user with a final output. By narrowing choices step by step, the wizard removes guesswork and provides a guided, more user-friendly experience. The workflow engine orchestrates specialized solver nodes, prediction, optimization, sustainability, and adapters into solving processes, SPs, that produce operational decisions. Each node encapsulates a model/algorithm or an integration with a typed I/O contract. The engine manages data flow, control flow, retries, and observability. This enables elastic, explainable, end-to-end decisioning without monolithic code. User story from the Greek Pilot UI. The user selects a destination airport and a required delivery time window and provides the cargo readiness time at the terminal. SP2 evaluates flight options that can satisfy end-to-end timing, exposing intermediate milestones, gate ETA to Gold Air, screening windows, slot completion, and finally returns the set of feasible flights. Let's follow how data flows through the engine to deliver real-time, predictive logistics intelligence. It all begins when the system receives API-initiated data from connected stakeholders, port authorities, logistics operators, and warehouse systems. The engine authenticates the request, validates the input, and normalizes it according to corridor-specific rules and service-level constraints. This ensures consistency and trust from the very first data exchange. Next, the engine processes the incoming data, aligning timestamps and generating unified context vectors for each operational segment: port, road, and warehouse. These context vectors allow the system to build a comprehensive, real-time picture of cargo movement across the multimodal chain. Once the context is established, the first solver, GR_02, predicts the total stay of cargo at the terminal or port. This determines the processing completion time, or T_proc, which becomes the foundation for all downstream predictions. The next solver, GR_01, estimates the arrival time of the truck transporting the cargo, for example, from Costco to Gold Air. Using T_proc and current corridor conditions, the system calculates an ETA at the gate, establishing a baseline for synchronization across actors. With the truck's ETA known, the GR_07 solver predicts warehouse capacity at the destination, forecasting available storage and operational time windows. This step ensures proactive planning and avoids congestion during peak hours. Next, the GR_08 slotting and location assignment recommender defines the optimal slot plan, aligning incoming arrivals with available space and capacity. The result: seamless coordination between inbound logistics and warehouse management. The GR_04 solver then estimates warehouse dwell time, T_handling, based on staffing levels, slot allocation, and operational tempo. This prediction allows precise scheduling and efficient resource allocation. Parallel to that, the GR_03 module estimates screening time and identifies any compliance or precedence requirements. It outputs T_screening, ensuring regulatory checks are accounted for in the overall plan. Finally, the GR_12 Flight Feasibility Evaluator, a core module of Scenario Pilot 2, filters all possible flights based on the cargo's expected arrival time at the airport. Only those matching the operational window are retained, ensuring time-critical shipments meet their delivery commitments.
The workflow engine then formats the response, presenting the feasible flight set within the requested delivery window. It generates a complete milestone timeline, from port departure to final air transport, enabling end-to-end visibility and actionable insights for every stakeholder. This orchestrated flow exemplifies the power of the 4Freight platform, connecting systems, predicting outcomes, and optimizing multimodal freight logistics, paving the way toward a truly intelligent and sustainable European transport ecosystem.
The solver onboarding page allows developers to deploy their own solvers and integrate them with the 4Freight platform. To facilitate the whole process, a set of 5 steps is introduced, and once every required info is input, the solver should be readily available for use within the 4Freight platform. The first step contains information related to the solver's version, developer, license, what its category is, and a description. This information will later be displayed in the marketplace. The second step is to gather information on solving processes this solver is a part of, if any. The third step is where the various endpoints the solver makes available are defined. In this step, the method, path, and the description of the endpoint are introduced along with any expected inputs and outputs for each endpoint. These are very important as they allow the solver to be fully integrated with other aspects of the platform, such as the solver marketplace and the visualization tab. Step 4 defines the location or locations where this solver is most likely to see use, mostly for information purposes, but at least the country of origin should be introduced here. The final step is related to the actual solver code. For this step, you need only to have a previously built image in any public repository of your choice and add the image name, the version or tag for the image, and the port used. Once submitted, the platform will run the services responsible for not only storing this information but also deploy this solver to the platform. And, if everything was introduced correctly, the solver can be found and used a few seconds later through the solver marketplace page. Similar to the solver onboarding page, The solving process onboarding page lets developers introduce their solving processes to the platform once it has been defined via the workflow engine. This onboarding process is done in 3 steps, which result in the addition of the solving process in the solving process marketplace so it can be conveniently used at a later date and make use of other components such as visualization purposes. The first step contains information about the solving process, and this information is what will first be seen in the marketplace. Should you wish to, you can add additional information such as the real-world problems it aims to solve or the intermodal interfaces affected by it. The second step is where the information on the various solvers that were used towards the solving process is introduced, as well as any external legacy systems that may be used as part of the solving process. Third and final step, similarly to the solver onboarding process, collects the information related to the API endpoints for the solving process. Again, this step is extremely important as the information, such as the expected inputs and outputs, will be gathered at this point. This will allow for the solving process to be seamlessly integrated with some of the platform's underlying components and allow users to make full use of all of its functionalities. Keep in mind this information needs to align with what has been introduced in the platform's workflow engine. Once submitted, the solving process will be available for use in the solving process marketplace page. Bridging the gap between innovation and real-world operations, the 4Freight platform opens new pathways for collaboration across Europe's transport network. Together, we're shaping a smarter, more resilient, and sustainable freight ecosystem.